Hi, welcome back to mathematics classes. This time I'll take one of the important shortcut on definite integral, which is quite useful for KCET exams. One of the important shortcut on a definite integral. Given the list of the shortcuts here. Okay, it's based on property 4 and property 5 of a definite integral actually. Okay, we know property 4, the property of the definite integral. I'm telling the property 4, integral from a to b f of x dx equal to integral from a to b f of a plus b minus x dx. That means you can replace x by lower limit plus upper limit minus x. The value of the definite integral is not going to change. That is property 4. What I repeat once again, integral from a to b f of x dx equal to integral from a to b f of a plus b minus x dx. Property 5 says integral from 0 to a f of x dx equal to integral from 0 to a f of a minus x dx. Property 5 says that the value of the definite integral is not going to change even though you replace x by upper limit minus x. Lower limit is 0, so replace x by upper limit minus x. The value of the definite integral is not going to change. Here is a list of important shortcuts so that you can crack in 5 seconds. Okay, problems based on this. Integral from 0 to pi by 2 f of sin x by f of sin x plus f of cos x. Answer is pi by 4. Sin by sin plus cos. In short, I can tell integral from 0 to pi by 2 sin by sin plus cos is pi by 4. Integral from 0 to pi by 2 cos by sin plus cos pi by 4. Because sin and cos are co-functions. You know that sine and cosine functions are co-functions, correct? Sine of pi by 2 minus x is cos x and cos of pi by 2 minus x is sin x. That we learned already in allied angles trigonometry, correct? Because of that property we have this, okay? And tan and cot are co-functions, right? So integral from 0 to pi by 2 tan by tan plus cot is equal to pi by 4. The same as integral from 0 to pi by 2 cot by tan plus cot, because tan and cot are co-functions. Same way we have sec and cosec are co-functions. So integral from 0 to pi by 2 function of sec by function of sec plus function of cosec, answer is pi by 4. Is also equal to integral from 0 to pi by 2 function of cosec by function of sec plus function of cosec, answer is pi by 4. In short, I can tell integral from 0 to pi by 2 sin by sin plus cos, integral from 0 to pi by 2 cos by sin plus cos, integral from 0 to pi by 2 tan by tan plus cot equal to integral from 0 to pi by 2 cot by tan plus cot, integral from 0 to pi by 2 sec by sec plus cosec equal to integral from 0 to pi by 2 cosec by sec plus cosec. Everything is pi by 4. Okay, so I can give the proof of this based on the property. Okay, and also we have integral from 0 to a f of x by f of x plus f of a minus x is a by 2 is also equal to integral from 0 to a f of a minus x by f of x plus f of a minus x a by 2. More generally, we have integral from a to b f of x by f of x plus f of a plus b minus x b minus a by 2. Upper limit minus lower limit divided by 2 is also equal to integral from a to b f of a plus b minus x by f of x plus f of a plus b minus x. Both are equal to upper limit minus lower limit by 2. Okay, and also we got again the co-function property of sine and cos. Integral from a to b sine by sine plus cos is same as integral from a to b cos by sine plus cos is equal to upper limit minus lower limit by 2, provided a plus b is equal to pi by 2. Sum of the lower limit and upper limit is equal to pi by 2. Then it is answer of that integral is upper limit minus lower limit divided by 2. Tan by tan plus cot or cot by tan plus cot, upper limit minus lower limit divided by 2, provided sum of the lower limit and upper limit is pi by 2. Okay, a plus b equal to pi by 2. That condition is there. Sec by sec plus cosec, integral from a to b, sec by sec plus cosec, same as integral from a to b, cosec by sec plus cosec. Answer is upper limit minus lower limit by 2, provided the sum of the lower limit and upper limit is pi by 2. All these things quite useful. I'll give one or two proof of this. Okay, not everything. I'll give a proof of this. Take the integral as I. Suppose you take I is equal to integral from a to b f of x by f of x plus f of a plus b minus x. Take the integral as I. One or two I shall prove it, not everything. Call this as equation 1. Okay. Now what we'll do is replace x by lower limit plus upper limit minus x. Replace x by, according to property 4, one can replace x by lower limit plus upper limit minus x. a plus b minus x. Then I is equal to integral from a to b f of x becomes a plus b minus x divided by f of x becomes a plus b minus x plus f of a plus b minus of a plus b minus x will be x. I am replacing x by a plus b minus x. No. So this bracket becomes what? A plus b minus of a plus b minus x. Like this. Understood? So that this becomes equal to integral from a to b f of a plus b minus x divided by f of a plus b minus x plus a plus b minus a plus will cancel, minus of minus x becomes plus x, f of x. Now we can add equations 1 and 2. Call this as equation 2. Add equations 1 and 2. So denominator is same, no? So I'll add equations 1 and 2. Adding equations 1 and 2. Adding equations 1 and 2. Adding equations 1 and 2. We get what is I plus I to I is equal to integral from a to b. Denominator is same, no? Denominator of equation 1 and 2 is same. So taking common denominator f of x by f of x a plus b minus x. Taking common denominator. If denominator is same, we can add the numerator, correct? Numerator we add f of x plus f of a plus b minus x. F of x plus f of a plus b minus x cancels. So what do you get? 2i is equal to integral from a to b 1 dx. Correct? Numerator and denominator cancels out. They're same. Cancels out. So integral of 1. You know integral of 1 with respect to x is x. So x it is. Evaluate this from lower limit to upper limit. Substitute the function, evaluate the function in upper limit minus evaluate the function at lower limit. 2i is equal to b minus a. So I is equal to b minus a divided by 2. So value of the definite integral is upper limit minus lower limit by 2. Hope I understood this. F of x by f of x plus f of a plus b minus x is upper limit minus lower limit divided by 2. Hope I understood. One more I'll take up. I given the proof of one of them here. I given the proof for fifth one. The first part of the fifth one I given the proof. One more I shall take the first one itself. Okay. 0 to pi by 2 f of sin x. One proof I given here. One more proof I'll give for the first one. Take the integral as I. I is equal to integral from 0 to pi by 2 f of sin x by f of sin x plus f of cos x. Similarly, you can try the proof of the rest part. Okay. We'll take up the problems based on this. Take this as equation 1. Using property 5, because the lower limit is 0, I replace x by upper limit minus x. Upper limit is pi by 2. So replace x by pi by 2 minus x. Replace x by pi by 2 minus x. Replace x by pi by 2 minus x. I is equal to integral from 0 to pi by 2 f of sine of pi by 2 minus x. Correct? Divided by f of sine of pi by 2 minus x plus f of cos of pi by 2 minus x is equal to integral from 0 to pi by 2 f of, we know sine of pi by 2 minus x is cos x, concept of allied angles. Sine and cos are co-function, right? Pi by 2 means 90 degree. 90 degree means co-function. Co-function of sine is cos. Sine of pi by 2 minus x is cos x. Divided by f of sine of pi by 2 minus x is cos x plus f of cos of pi by 2 minus x is sin x. Call this equation 2. Adding equations 1 and 2. We'll do this because denominators are same. Adding equations 1 and 2. we get I plus I, 2i. 2i is equal to integral from 0 to pi by 2. Denominators are same, f of sin x plus f of cos x. Denominators are same, so add the numerators, f of sin x plus f of cos x. F of sin x plus f of cos x, correct? If denominators are same, we can add the numerators. That is what I have done. And numerator is same as denominator, so ratio becomes 1, right? So what I get? 2i is equal to integral from 0 to pi by 2, 1 dx. And we know integral of 1 with respect to x is x, correct? Integral of constant is constant into x. If you are integrating with respect to x, integration with respect to x, that matters. You are integrating with respect to which variable, that matters. Integral of constant is constant into x. Integral of 5 is 5x. Integral of 100 is 100x. Suppose you are integrating with respect to x. Now I am integrating 1 with respect to x. So 1 into x is x. Limits from 0 to pi by 2. 0 to pi by 2. That is equal to pi by 2 minus 0. 2i is equal to pi by 2. That means I is equal to pi by 4. Value of the integral is pi by 4. Understood? Remaining you can try if you are interested, or just learn the results. That's more important. Proof nobody asks in the CET exam or any competitive exams, but you must know how it is being derived. Okay, if you understand the derivation, so that you can remember better. Okay, once you learn it, you should not forget it. Like that you should learn. It should be like English alphabets. You learned it many years back, still you remember it, correct? Like that you should learn all the mathematics formulas or equations. Mathematics is a subject made up of formulas and equations only. So you have to learn the formulas and equations. Then only it's possible to solve the problems. Okay. So I given the proof of 2 of them out of so many, 8 were there results. Now we should take the problems based on this. Okay. Apply those results in working out the problems so that we can crack the question in very less time. Okay. We take the problems now. The first one, integral from 2 to 8 root of 10 minus x by root x plus root of 10 minus x with respect to x. Question asked in KCET 2016. Hope you understand. The function, the given integral takes the form f of x by f of x plus f of a plus b minus x. Or I can read this as integral from a to b, no? A lower limit is 2, upper limit is 8. Lower limit plus upper limit is 10, correct? 2 plus 8 is 10. You can see 10 minus x within the root. So I can compare this with integral from a to b f of a plus b minus x divided by f of x plus f of a plus b minus x. I can compare the given integral with this, correct? So that you see a is 2, b is 8, so a plus b is 10. What is my function f of x? Where f of x is root x. Where f of x is root x. The function takes this form. The given integral takes the form. Integral from a to b, f of a plus b minus x by f of x plus f of a plus b minus x. Answer is b minus a by 2. b minus a by 2. Correct? Upper limit is 8, lower limit is 2. So answer is 8 minus 2 divided by 2. 6 by 2 is equal to 3 over. 5 seconds enough. F of a plus b minus x by f of x plus f of a plus b minus x, where f of x is root x. 2 plus 8 is 10, correct? So x has become 10 minus x. Wherever there is x, it has become 10 minus x. Understood? Given integral takes this form. Answer is upper limit minus lower limit divided by 2. 8 minus 2 by 2. 8 minus 2, 6. 6 by 2, 3. Over. Very simple question. Option D is the answer. Correct? 3. Option D. Next one. Here, question asked in KCET 2023. Integral from 2 to 8, 5 power root of 10 minus x by 5 power root x plus 5 power root of 10 minus x. Even this integral takes the form integral from a to b f of a plus b minus x, correct? Divided by f of x plus f of a plus b minus x. F of a plus b minus x with respect to x. What is my function f of x? Where f of x is 5 to the power of root x. Function takes the form f of x is 5 power root x. Correct? f of x is 5 power root x. So that f of a plus b minus x, a is 2, b is 10, 2 plus 8, 10. If you find f of 10 minus x, a plus b, no, a is 2, b is 8, correct? F of 10 minus x, f of 10 minus x is equal to how much? 5 to the power root of 10 minus x, correct? F of a plus b minus x. What is the answer? B minus a by 2. Upper limit minus lower limit divided by 2. 8 minus 2 by 2. 8 minus 2, 6. 6 by 2 is equal to 3. Done. Very less time we can answer. I am explaining it in detail. That's why I am taking more time. You can crack the question in very less time. Looking at the question, directly you can answer. Upper limit minus lower limit by 2. Answer is 3. Option A. Move on to the next one. Integral from pi by 6 to pi by 3 sin cube x by sin cube x plus cos cube x. It is of the type sin by sin plus cos. You look at the lower limit is pi by 6, upper limit is pi by 3. Pi by 6 plus pi by 3 is pi by 2. This integral takes the form integral from a to b f of sin x by f of sin x plus f of cos x. F of sin x plus f of cos x. This integral takes the form like this. Answer for this is upper limit minus lower limit by 2. The condition is a plus b is equal to pi by 2. Lower limit plus upper limit is pi by 2. In that case, we get this. So lower limit plus upper limit. Pi by 6 plus pi by 3 is pi by 2. Pi by 6 in terms of degrees, 30 degree. If you are not comfortable with radian, you convert it to degrees. Pi by 6 radian is 30 degree. Pi by 3 is 60 degree. 30 plus 60 is 90. 90 is pi by 2. So sum of the lower limit and upper limit is pi by 2. Correct? So that I can apply this formula. Answer is for that integral is what? Upper limit minus lower limit divided by 2. Pi by 3 minus pi by 6 divided by 2. Pi by 3 minus pi by 6 is pi by 6. Pi by 6 by 2 is pi by 12. Answer is option C. Over. In less than 5 seconds we can answer. Understood? Integral from pi by 6 to pi by 3 sin cube x divided by sin cube x plus cos cube x. Sin cube x plus cos cube x. What is the answer? Upper limit minus lower limit divided by 2. Pi by 3 minus pi by 6 is pi by 6. Pi by 6 by 2 is equal to pi by 12. Option C is the answer. Okay. Very simple one. Question asked KCET 2012. Move on to the next one. Question number 4. Integral from 0 to pi by 2 sin 400x by sin 400x plus cos 400x. Answer is pi by 4. Already told the first result. Integral from 0 to pi by 2 sin by sin plus cos. Answer is pi by 4. Option D is the answer. If you're doing the method, I can do the method if you want. In detail, if you're doing the method like board exams, those are not understood. I'll do the method in detail. 0 to pi by 2 sin power 100x divided by sin power 100x plus cos to the power 100x. Even for board exam, these kind of questions can be asked for 6 marks. One question is guaranteed for Karnataka PU board exams. I'm telling you, 6 marks question in the part E of the question paper, along with LPP, linear programming problem. Solved graphically, they'll ask one question, LPP problem. And another one is on definite integral. Property and the problem will be asked. Property proof and the problem will be asked totally for 6 marks. Okay. So if you're doing the actual method, take this as equation 1. Replace x by pi by 2 minus x. Sin becomes cos and cos becomes sin. Add equations 1 and 2, get the answer. Replace x by pi by 2 minus x. I is equal to integral from 0 to pi by 2. Replace x by pi by 2 minus x. What do you get? Sin to the power 100 of pi by 2 minus x divided by sin to the power 100 of pi by 2 minus x plus cos to the power 100 of pi by 2 minus x. Actually, we know the answer, pi by 4. I am doing the method just to make you understand if you have not understood it. Integral from 0 to pi by 2. Sin of pi by 2 minus x is cos x. So this becomes cos 400x divided by sine of pi by 2 minus x is cos x. So cos 400x. And cos of pi by 2 minus x is sin x. Sin and cos are pair of co-functions, correct? Whenever pi by 2 comes, pi by 2 means 90 degree. 90 means co-function. Co-function of sin is cos and co-function of cos is sin. So cos of pi by 2 minus x is sin x. This becomes sin to the power 100x. This is equation 2. Add equations 1 and 2. Adding equations 1 and 2, we get I plus I is 2i. 2i is equal to. Why I am adding equations 1 and 2? Because the denominator is same. Denominator is same. Sin power 100x plus cos power 100x. Sin power 100x plus cos power 100x. Denominator is same. So add equations 1 and 2. Sin power 100x plus cos power 100x. Cancels, becomes 1. Integral from 0 to pi by 2 1 dx. Integral of 1 is x. Limits from 0 to pi by 2. Evaluate the function at upper limit minus evaluate the function at lower limit. 2i is equal to pi by 2. So I is equal to pi by 4. Answer is pi by 4. I have done this problem in detail. So make you understand. Answer is pi by 4. Quite simple question. Crack it within less than 3 seconds. Look at the question. Sin by sin plus cos. Answer is pi by 4. 0 to pi by 2. Over. Next one. Integral from 0 to 4042 root x by root x plus root of 4042 minus x. This takes the form in NCERT book only. We have a question like this. Integral from 0 to a root x by root x plus root of a minus x. Answer is a by 2. So answer is 4042 by 2021. Question asked in the year 2021. Answer is 2021. Correct? So this you can compare to integral from 0 to a f of x by f of x plus f of a minus x. F of x plus f of a minus x, where a is the upper limit. See, this is same. 4042, 4042. Answer is what? A minus 0 divided by 2. A minus 0 by 2. That is a by 2. Correct? Integral from 0 to 4042. Correct? Root x by root x plus root of 4042 minus x. Answer is a by 2, that is 4042 by 2. Correct? That is 2021. Upper limit minus lower limit divided by 2. Answer is 2021. Quite simple question. Move on to the next one. Question asked in KCET 1999. Integral from 0 to pi by 2. 2008 power sin x by 2008 power sin x plus 2008 power cos x. Function of sin by function of sin plus function of cos. Answer is pi by 4. Correct? This takes the form integral from 0 to pi by 2 f of sin x by f of sin x plus f of cos x. Answer is pi by 4. Sin by sin plus cos. Answer is pi by 4. Correct? Where f of x takes this f of sin x. F of sin x, that is 2008 power sin x. F of cos x, 2008 power cos x. F of x is 2008 power x second term. If I ask what is your f of x? F of x is 2008 to the power x. 2008 power x. F of sin x is 2008 power sin x. Function of sin by function of sin plus function of cos. Integral from 0 to pi by 2. Answer is pi by 4. Next one. Integral from 0 to pi by 2. Tan power 7x by tan power 7x plus cot power 7x. Answer is pi by 4. Takes the form integral from 0 to pi by 2. F of tan x by f of tan x plus f of cot x. Answer is pi by 4. Given integral takes this form. 0 to pi by 2. F of tan x divided by f of tan x plus f of cot x. F of tan x plus f of cot x. Function of tan by function of tan plus function of cot. Answer is pi by 4. With this, we'll conclude on one of the most important shortcut on definite integral. Okay, we'll do more shortcuts on different topics. Okay, with this, I'll conclude. Thank you.